Hi guys, if I'm audible, just write down in the chat or if my voice is clear and you are able to hear. Yeah, so I hope my screen is also visible to you. So how was the contest for you all? Okay, we'll start with the discussion in just 2 minutes. I'm from IT Dhanbad. For interactive, I guess you can practice random problems on CF only. CF only has interactive problems. And yeah, for some people, contest would have gone good. For some, it would be bad, but no issues. Just try to absolve if your contest was not good. Okay, so I think we can start with the discussion. So we'll discuss the first four problems. He also had got the logic, but didn't have time to implement. So slight debugging was left. So we'll not discuss E today, but we'll discuss the first four problems. Okay, so hi everyone, I am Abhinav, and let's start with the post contest discussion for the Codeforces Round 1044. Okay, so let's start with problem A. So Steve stumbled upon a collection of n gears where gear I has AI teeth and he wants to arrange them into a row. After he arranges them, Steve will spin the leftmost gear at a speed of 1 revolution per second. For each of the other gears, let x be the number of teeth it has, y be the number of teeth of the gear to its left, z be the speed of the gear to its left, the speed at which the gear to its left spins. Then its speed will be y upon x into z revolution per second. So basically, what does this statement means that so you are given a list of n gears and basically the number of teeth present for them is given in the form of an array, and the first gear spins at the speed of 1 revolution per second, and then the further gears, the speed of them are defined like this. So if you want to calculate for the second gear, then look at the gear to its left. If the number of teeth on it is y and its speed is z, then for the current gear the speed would be y into z divided by the number of teeth in the current gear. So Steve considers the contraption satisfactory if the rightmost gear spins at a speed of 1 revolution per second. So if the rightmost gear also spins at a speed of 1 revolution per second as the leftmost gear, then it is satisfactory. Determine whether Steve can rearrange the gears into a satisfactory contraption. Okay, so this is the problem, and if you just look at, let's say, we look at this test case. So basically we are given a n and an array of size n. So Steve has to just rearrange this array so that basically this array is given. Now you can rearrange it in any order such that after rearranging, if you calculate the corresponding speeds for each of the gear, then it's given for the first gear the speed is 1 always, and then for the next gears the corresponding speeds are calculated with the formula y into z by x, where y is the number of gears in the, like you can see, if I'm naming this array as a, then y is the value of the array at the previous index, basically the number of what is that, number of teeth in the gear to the left. So if I am currently at the ith gear, then I minus 1 would be basically my y, and z is the speed of the, if I'm this array I'm telling as the speed which I'm calculating, then the speed of the previous gear is z, and x is basically the ai, the current number of teeth. So this is what the current speed is given as. Okay, this is basically the formula. The current speed is given as speed of the current speed is given as number of gears in the previous, just to the left, into its speed divided by number of gears in the current. So with this formula, what you can like notice is basically if you simplify it, si multiplied by ai is equal to ai minus 1 into si minus 1. Basically through this what we can conclude that for the first gear it's given the speed is 1. So if I'm taking 6 in the first place, then 6 into 1 would be this product, and for the second gear si into ai should be constant. So this is calculated by this product divided by 3, then again this is calculated by this product divided by 6. So what we can conclude is that for every index, the product of its speed and the value, the number of peaks at that index, this product should be constant for every index. If this is constant, so satisfying this, our speeds are calculated. So speeds are assigned such so that this is constant. So if you just rearrange this array A, what you need finally is the first value, the speed of the first index should be 1, and for the last we should get 1. Okay, when we calculate it through this way, then we should get 1. Okay, let's say this was only our array. Okay, we didn't rearrange it, then what speed would we get at the end? Let's try to find out. So 1 is given for the first, so what would come here? This would be 6 into 1 divided by 3, which would be 2. So 2 would come here. What would come here? It would be 3 into 2 divided by 6. So that would be 1. What would come here? It would be 6 into 1 divided by 9. So 6 by 9, it would be 2 by 3. So for the last gear, the speed is 2 by 3, which is not equal to 1. So this you can say is not valid. So you need to basically rearrange this array so that it becomes valid. So what should you do to rearrange this? Now, for you are at the end, the speed you want to get should be 1, which should be equal to the first. So if the speeds are equal, then for them, the value of the array should also be equal. If they are equal, then it doesn't matter what all are there in the middle. Those speeds would be calculated something, but finally this value would come down to 1 if the first and last value in the array are equal. So basically what we need to do is, you can rearrange this array A into, you can have swap this 6 this side and make it 6 3 9 6. This way, if the first element is equal to the last element, then you can always say that the speeds would also be equal according to this formula that we put. So how do you check whether you can make it or not? So it's pretty simple. If you want to check that in an array, you are given, then you can just shuffle this array in any order, and after shuffling you should have the same element in the first and last index. When is it not possible? It's only not possible if all the elements of the array are unique. So if all the elements are unique, then it would be not possible to have the same value in first and last index, because one value doesn't exist more than one time. So we just need to check that if all elements are unique, then our answer would be no. Otherwise, our answer would be straight away yes, that it would be possible through some way. I hope this logic is clear to you. Okay, is there any doubt in this logic? So then the code would be simple. How do you check whether all the elements in an array are unique or not? One way is just you can put all the elements into a set. If because a set stores only unique elements, if the size of the set is same as the size of the array, that means all the elements would be unique. If it is less, that means they are not unique. So that is the logic that we are using for the code of problem A. I take the input and then I initialize a set. I put all the elements of the array into the set. If the size of the set is less than n, that means all the elements are not unique. We print yes. Otherwise, all the elements are unique. We print no. Okay. I hope the first problem is quite clear to everyone. Is there any doubts in the first problem, or should we move to the second? Okay. So I think all of you have solved the first problem. So I think we can quickly move to the second problem. So the second problem is Steve lives in a village with n other villages. Unfortunately, due to disputes over the distribution of emeralds, none of those villagers are friends with any other villager. Furthermore, villager I initially has a grumpiness of GI. Okay, so basically there are n villagers and none of them are friends with any of them. And every villager has a grumpiness value given by an array G. Gi is the grumpiness of ith villager. Steve can perform following operations any number of times. Select two villagers I and J. Then whatever is the maximum among both the Gi and Gj values, that is the number of emeralds that would be required to share. And after that, the grumpiness value of both of them would decrease by min of Gi and Gj, and they would become friends if they weren't already. Okay. So through these operations, you can make two villages friends, but it would cost you this much amount of emeralds, and it would also decrease their grumpiness values by the minimum. Now, Steve wishes to make every villager friends with every villager, possibly through some intermediate friendship. So he should make every villager friends with every other villager, and intermediate friendships also count. So if villager A is friend with B and B is friend with C, you can say that A and C are also friends. That's what intermediate friendship means. That is, from any villager, you can follow a path of friendship to reach any other villager. Since he does not want to inflate the village economy too much, calculate the minimum number of emeralds he must give away to accomplish this. So you just need to calculate in what is the minimum number of emeralds he need to spend to basically achieve this, that all villagers become friends. Okay. So I hope if the problem is clear, let's look at one test case to understand more clearly. Okay, so this example, you can see that you are given an array of size n. So this represents the grumpiness value, Gi. Okay, so this is, let's indent them one based only. So villager 1 has a grumpiness value 2, 2 has a 1, 5, 2, like this. So how can you, currently all the four are separate, none of them are friends with anyone. What you need to achieve is basically, let's say you apply an operation on these two, then they would become friends. Maybe then you apply an operation on these two, they would become friends. Okay, so you can make them friends, and then maybe apply an operation on these two and make them friends. Once all of them become connected, like you can imagine this, like those are individual nodes in the graph, and you have to make all of them connected, a single connected component you have to make, if you want to understand it like a graph. But actually graph is not needed if you don't know. Just you need to know that the minimum number of operations that you would like at least have to perform to make all the n villages basically connected, or all of the m of them friends, would be like for 4 villages you would require at least 3 operations. So like for n villages, at least n minus 1 operations would be required to make all of them friends. You can perform more than n minus 1 operations, because it's allowed. If 2 are friends, still you can perform operation on them, but the minimum that you require would be n minus 1. Okay, so even if they were friends, you can still apply the operation, but that won't have any effect. It would only cost you emeralds, and it would have this effect of decreasing GI and GJ value. So now with this given G, what is the minimum number of emeralds you would have to spend to make all of them friends? So for this case, what would be the minimum way to do that? What you can do is maybe use and apply an operation on these two. Okay, so the number of emeralds spent would be max of 5 comma 2, which would be 5. So 5 emerald will be spent, and these two values would decrease by min of 5 comma 2, which is 2. So you would do a minus 2 to both of these values. So after doing a minus 2, basically 5 would become 3 and 2 would become 0. Okay, now with this new array, again you can apply operations. Next, what should you do? Let's say you can apply an operation on these two values. Okay, so the max of 2 comma 1 would be 2. So 2 emerald will be spent here, and the min of 2 comma 1 is 1. So you would subtract both values by 1. So a minus 1 to both values makes the array this. Okay, now in this array, now you can see you applied one operation here, so these two are now connected. You applied one operation on here, so these two are now connected. So you only these two, like this one component and this one component separately are connected. You just need one friendship between any one person from this component and one person from this component to make all of them friends with each other. Okay, so what can you do? What should you do to minimize your emeralds? These are 0 0, so you can perform an operation on these two. After this, all of them would become friends, and your cost for this case will be max of 0 comma 0, which will be 0. So with a total cost of 5 plus 2 plus 0 is equal to 7. With a total cost of 7, you are able to achieve this, that all of the 4 are friends with each other. Okay, so for this test case, you can see your answer was 7 for the second test case. Okay, so I hope the problem is clear what you need to do. Now, how do you like optimally do it? The constraints are n is up till 2 into 10 power 5. So you have to do something in order of n only. Okay, now if you think what is happening with the operation. Okay, so there are two things. The cost for each operation is max of whatever ai comma aj or gi comma gj, right? This is the cost. So this cost would be required, but it would also do one thing, that it would reduce both gi and gj. They would get reduced by min of gi comma gj. So what does this operation does? So if I'm assuming, let's say gi is my smaller value, ga is my gj is my greater value, let's assume for now, then reducing them, the min of gi gj would be gi. So basically gi would get reduced to 0 and gj would get reduced to gj minus gi. Okay, so after the operation, if I'm assuming gj is greater, then the greater value, whatever is the greater value, would be the cost, and the smaller value would become 0, greater value would become the difference of gi minus gj. Okay, so with this in mind, always whenever you apply an operation, one of the value is becoming 0. Okay, so now you can see, if you have an array G of size n, you want to make all of them connected. So you would require at least n minus 1 operations, but you want to minimize the cost. So let's say I sort the array in descending order. This has the greatest value and this has the smallest value. Okay. Whatever is the greatest value. Okay. Initially, when you have this complete array, you would apply at least one operation. Now, whatever is the greatest value, you it would never happen that this value would become zero, and you can, because this is the greatest value, the value that becomes zero would be the minimum of the two values that you choose. So this would never be the minimum of the two values. So with this you can know that in order to make this friend with anybody else, at least one operation would be required using this. And if you are using this in an operation, then this value would definitely get added. This would be the maximum value. So you can say that whatever is the maximum value, that would get added at least one time. But after this gets added, this would get reduced by whichever you pair it with. Okay. Now what about the second maximum? Okay. This was, let's say, the maximum. Now G2 is the, let's say, the second maximum. So do you always need to use this G2, this second maximum, add this G2 to your answer? What you can do is, if you, the only way you can avoid adding G to your answer is if you pick it along with G1. Okay. If you pick it along with G1, then you would add G1 to the answer and this G2 would become zero. Okay. Once this G2 becomes zero, then you can actually make it friends with other zeros with zero cost only. So this you can realize that after every operation, you are making one of them zero. After every operation, you are making one of them zero. So like after n by 2 operations, you would have n by 2 zeros. Now, once you have n by 2 zeros, like you can use two of the zeros and make them friends with each other. This way, like you can extend the friendship with zero cost only. So like the most greedy and optimal way here would be, I guess you would have got a bit of logic from here, that this one you would have to use, but this one you can avoid by pairing with it with this and making it zero. Okay. Then what about G3? G3 you can avoid. G3 you can avoid by pairing with either this one or this one. So let's say you pair it with this one, then you would have to use plus G2. And if you pair it with this one, then you would have to use plus G1. But if you have already paired it with this G2, then this G1 would have like reduced by a cost of this G2. So in that case, if this G1 has reduced by the cost of G2, what you can do is basically, instead of pairing it with this one, okay, let's say you can avoid it with pairing it with G1, but then you would also have G4, G5. So if you like pair all of them with G1, then like once this G1 gets below G3, then G3 cost would be used. If it gets below G4, G4 cost would be used. So basically all of these costs would consecutively get used. So a more optimal way would be pair these two, you get a zero. Then pair these two, you would get a zero here, and this plus G3 would be used. Okay. Here you used plus G1 in your answer. Then you got a zero and plus G3 got used. Then if you have G5, G6, uh, G7, G8, let's say n is 8, then you can pair these two, you got a 0 and plus G5 was used. You can pair these two, you got a 0 and plus G7 was used. After n by 2 operations, after these 4 operations, this much cost was used, okay, and you were able to pair up these two together, these two together, these two together, these two together. Now in every component, you have a value which has a value 0. In this also you have a 0, in this also you have a 0, in this also you have a 0. Now if you want to connect them together, make all of them friends, you can use zeros to connect them together, zeros to connect them together, zeros to connect all of them together. Then no extra cost would be required. So basically what you need to do is you can pair them like this, all the adjacent elements after sorting them in decreasing order. Then this greatest G1, G3, G5, G7, these odd costs would be required. But after that, no extra cost would be required, as you would get zeros through which you can make all of them friends using zero operation. So basically a greedy way to do to solve this problem is just, so basically your final answer is just sort the array G and take the sum of all the odd indexes G1, G3, G5, G7. That would be your final answer. I hope the logic is clear to you. Okay. So, is there any doubts? I've not given you an exact proof, but I think intuitively you can understand why this is working. So, if you still have any doubts, then maybe you can ask. Should we move to the code? Okay, let's look at the code. So, for problem B, code is now quite simple once you get this logic. I take the input. After that, I sort the array in descending order, and then my answer is just traverse to all the alternate indexes. So this array is zero based, so I'm traveling to even indexes 0 to 4. Here it was one based G1, G2. That's why I was writing G1, G3, G5. If it is zero based, it would be G0, G2, G4. So it's zero based, so I'm iterating uh, I equal to 2 and I plus equal to 2, all the even indexes, adding them up to my answer and print my answer. That's it. And the time complexity for that would be simple, order of n. I, uh, for sorting, it would take order of n log n. So overall time complexity would become order of n log n. This thing would be done in order of n. Okay, I hope it is clear. So I think we can move to the next. Any proof um like intuitively I explained you can prove this, but if I want to provide a formal proof, then like basically you can understand that if this is one way to get this as an answer. Now you want to prove that any answer less than this doesn't exist. So if you try any other way, like if you take G1 with G2 and then G1 with how can I say this? So if you try like any other way, then in n by 2 operations, if you are not taking different pairs, then you would never get n by 2 zeros. Okay. If you are using an already used value again, then you won't get an extra zero. Basically, you may not get an extra zero. Oh, okay, you'll get an extra zero, but you'll be using like maybe G3 here, and even if you are using like G3 here, it's same as this. And if you want to use something less than Z3, then whenever you are combining it with this, you are taking the max. Okay. So if you are combining it with this, you are taking the max of G1 and G3. So this would never be less than G3. It can be equal to G3. Okay. Whatever, if G1 gets reduced after G2, it can get reduced from G3. But when you are taking max, it would be at least G3. So same for G5. If you want to connect it, then at least G5 would be used. So basically this much is always getting used. If you're not using any one of them, then you basically cannot, if you're not doing n by 2 operations, at least on different numbers, n by 2 g values, till then you cannot combine values without using like anything. So at least n by 2 values of the array would be required that you would have to add. And that should be like, as I proved that G1 is at least required. So you cannot say that the last n by 2 values you would take, because according to proof that G1 would be required. So I think intuitively you would have read that at least n by 2 values would be required. And for that, the most optimal is take the greater odd values and get n by 2 zeros. Okay. So I think we can move to the next problem. If you want to get more formal proof, I don't have currently. Maybe I'll write in the comment, or you can look at the tutorial. Maybe it will be there. Okay. So let's move to problem C. So this is an interactive problem. Okay. So having recently discovered the Nether, Steve has built a network of n Nether portals, each at a different location in his world. Each portal is connected in one direction to some number, possibly zero, of other portals. To avoid getting lost, Steve has carefully built a network of portals, so there is no sequence of jumps through portals that will bring you from a location back to itself. Formally, the network forms a directed acyclic graph. Basically, with all these statements, what is written is he, there is a DAG. There is a directed acyclic graph. Okay. Uh, and the nodes of the graphs are basically and these portals. Okay. So the portals form a directed acyclic graph. Now, Steve refuses to tell you which portal are connected to which, but he will allow you to ask queries. In each query, you give Steve a set of locations. Okay, so now you need to query, and in each query, you can give a set of locations. So out of the n locations, n portals from 1 to n, you can pick some subset of that n locations, and that set you can give along with a x, which should be the starting location, which should belong to this set. Okay, then Steve will figure out the longest path starting at x that only passes through locations in S and tell you the number of locations in S. So you basically need to, so Steve will return you the longest path starting from X and only considering the nodes present in this set that is given by you. Okay, so all those nodes not present in this set will not be considered. So if you only consider these nodes, then among these nodes, what is the longest path starting with X is what Steve would return and tell you the number of locations in. He would just tell you the number of locations in this longest path. He won't give you the exact path, but the number of locations in the longest path. If it is impossible to reach any other location starting from X, he would reply you with 1. So if you start with X and you cannot reach any other location, basically only X is a single path with a single node. So he would return you 1 in that case. Okay. So now, as you are looking to obtain this, you want to find path that visits as many locations as possible. Steve is feeling particularly generous and will give you 2n queries to find. So you just basically need to find that in this given tag, what is the longest path. You need to find the longest path in this given tag, and you can use 2n queries of this type to find it. So you don't need to find the length of the longest path, but exactly the path. As you can realize, if you want to just find the length, you can just query with all the values in the set, starting with all the different x, all the different n as x. You can get the length through that, but you need to get the exact paths, exact nodes. So in your final answer, you would print like this, exclamation mark, and then the length of the path along with all the nodes present in the path. Okay, so this is the problem. If you just look at this one test case, so this was the network initially given to you. Okay, then what he did is the first query was that this was the subset of nodes selected and x was given as 1. So Steve would return that starting from node 1, what is the longest path among these nodes? 1, 1, 2, 3, 4. So this 5, you can say that just excluding this 5, among these nodes, what is the longest path? So longest path here, you can see would be from 1 to 4, 4 to 3. I think this would be the longest path having 1, 4 to 3 distinct locations. 1, 2, 3. Okay. So for this query, Steve returned you 3. Okay. Now the next query is x is 3 and 2, 3, 4 are the locations. So 2, 3, 4. So these two locations are excluded. So excluding them, if you start with 3, what is the longest path you can get? So 3 to 4 and 4 to 2. This is the longest path you can get of length 3. So 3 is returned by Steve for the query. Same way then, if you start with 5 and include only 1 and 5. So you want to check only in 1 and 5 and start with 5. So from 5 you can go to 1. So this would be 5, 1 would be the path having 2 distinct locations. So answer for the query was 2. Okay. Now with these conclusions, uh, so yeah, one more query was raised with starting with 2 and only 2 4. So if we are considering only 2 and 4 in the set and you start with 2, then you cannot reach 4 from 2 because this edge is a directed edge. So only 2 is present and you cannot reach anywhere else. So you would return 1 as the answer for this query. So I hope you understood how the queries are working. After making these queries, you concluded that the final longest path is 5142. So 5142. This path having a length of 4 is the longest possible path in this tag. So that you returned by this exclamation 4 and 5142, the exact path. You can see you cannot have a path with all 5 members in this tag. Now, how do you determine this? What kind of queries should you make in order to get this answer? Let's try to think. And the limit for the queries is just 2n queries. Okay. In 2n queries, you need to answer this. Okay, so let's try to find it. So basically, you are given some DAG. Okay. So let's draw a DAG here. Something like this. DAG is given to you. Now, it has n nodes. You want to use those queries in such a way so that you can get the longest path. Now, what does the queries return? If you give a set of nodes to it along with a starting point as x, it would return you the longest path starting from that node in this subset. So instead of just ignoring any nodes, let's say in the set we give all the nodes and nodes from 1 to n. If you give all the nodes from 1 to n, that would basically return the longest path in your DAG starting from node x. What do you need to find? You need to find the longest path in your DAG starting from any node. So you can just make n queries starting from node 1, x equal to 1, x equal to 2, likewise with x equal to n. You can make all these n queries and the set you would use would be all numbers from 1 to n. This way, for whichever query you get the maximum answer, that way you can get what your length of the path should be. Whatever is the maximum answer, that is basically the maximum length of the path that you can get in the tag. So this way you can get the maximum length for the length of the maximum path. But you also need to get the exact path. So how do you get the exact path? Now you have used these n queries. You still have 2n queries in total. So you still have n more queries that you can use to get the exact path. So once you have obtained the length, now just try to think what else can you check using these queries. Can you check whether there exists an edge from a node to another node? Now this graph is not visible to you initially. You can only get the answers to the queries. So like you did all those queries, for some x you got 1 as your answer, for some you get 5 as your answer, 3 as your answer, different answers you get. The maximum was, let's say, 5, so longest path was 5, but you are not getting that from which node to which node you have the path. So is there a way to get to check whether, if I'm telling node x and node y, if I give you two nodes, node x and node y, can you check whether there exists an edge, a directed edge from node x to node y using the given type of queries? Yes, you can check. What you can do is, if you want to check whether there exists a path from node x to node y, you can query with the given set as just x and y and given x as x. Okay, so if you query with x and x comma y as the given set, then if the answer for that query is 2, that means there is a path from x to y and there are two distinct nodes. And if there wasn't a path from x to y, the answer for the query would be 1, that you cannot travel from x to any other node. Basically you cannot travel to y. So this way, using one query, you can just check, if you want to check whether there exists a edge from node any node I to node j. This can be checked by doing this type of query. Now, once you know this information, how can you get the exact paths in this? After doing this n queries, you have got the length of the maximum path. How can you get the exact paths? So let's say for this particular DAG, okay, if I'm looking for this DAG, what was the maximum path here? 1, 2, 3, 4, 5 from this side, and maybe 1, 2, 3, 4, 5 from this side, 4, 1, 2, 3, 4, 5 from this side. So there are two, three ways through which you can get 5, but I don't think there exists a path with a length greater than 5 in this DAG. Okay. So let's say I want to get this path of size 5. So when I did do those n queries, then whatever, let's say this is node number 1, this is node number 2, 3, 4, 5, let's say 6, 7, 8, 9, 10. Okay, I have numbered these 10 nodes. So for x equal to 1, in this case, you would get 5 as your answer. Okay. So for x equal to 1, when you are taking the complete set, you would get 5 as the response for your query. For x equal to 2, the longest path from here was 1, 2, 3, 4. This side also 1, 2, 3, 4. Okay, sorry, it should be 6 because the number of edges is 5, but number of nodes is 6. So 1, 2, 3, 4, 5, 6. There are 6 nodes in the path, so it should be 6, not 5. Okay. And for x equal to 2, there are 1, 2, 3, 4, 5 nodes in the path. And like anyway, even if you take this path, there will be 5 nodes only. Even if you take this path, there will be 5 nodes only. Okay, you cannot have more than 5 nodes starting with x equal to 2. Answer for this query would be 2. For x equal to 3, your answer would be starting with 3, you cannot get more than 4. For x equal to 4, your answer would be starting with 4, you cannot get more than 3. X equal to 5, your answer would be 2. X equal to 6, your answer would be, starting from here, you can get 1, 2, 3, 4. This 4 length path, or from here also 4 length path. So 4. And x equal to 7, you would get 1, 2, 3. X equal to 8, you would get only 1 and 1, 2. X equal to 9 also, there is no path from here. This is the last element in the DAG if you are looking it like a topo sorted order. Okay, I hope whenever you want to imagine a DAG, you should imagine it as I have written it here in the topo sorted order. This way you can always check that starting from one node, where all you can reach and what is the longest path. If it is not in topo sorted order, then it would be confusing to see. So here you can directly see that you would always move to the right to get to any path. So for 9, it would be 1. And for x equal to 10, it would be 2. Now, you have made these 10 queries, got these values. By looking at these values, can you guess your path? So the maximum value was 6 for node 1. So whatever was the maximum value, you can guess that your path should start with this node number 1. And what should be the next node in the sequence? It should be such a node for which the maximum length of the path is 6 minus 1, which is 5. Because this you can understand if like what is the algorithm to find the longest path in a DAG. You do the topo sort and you write that dp of I starting with node I, the longest path is whatever is the parent of I, whatever, like you can say that whatever are the childs of I. If I'm telling j is a child of I, then dpj plus 1 maximum among all j which belongs to child of node I. Okay, so this is like the algorithm to find the longest path in a DAG. So through this, like you can understand that whenever if your dp of this dp1 is 6, the longest path is 6, that should come from some node whose longest path is 5. So if you check all the nodes for which you are getting 5, then among them, if there was, let's say, another node through which you get a 5, So node number 11. Then from here also you would have a length of 5. But there is no edge from 1 to 11. So this is also a value. This can also be the next node in your sequence. 6 only exists for one node number 1. So for your path, 1 is fixed as the first node in your path. What should be the next node? Next node should have the answer for the query as 5. So if both of these have an answer 5, then you would have to check for which node there exists an edge from 1 to 2. If there doesn't exist an edge from 1 to like 11, then you cannot have a path from 1 to 11. So what you can do, whichever has the maximum value, select that as your first node. Then check the next maximum value, 5. So store all those values of x for which you get 5 as the answer for the query. Among them, check, just find any one such node for which there exists a edge from 1 to 2, from the previous node to that node. If there exists an edge, and how to check that? Through this type of query, as I explained earlier, you can check. So if there exists an edge, that is the next node in your path. Okay. So here the edge didn't exist, but here it existed. So you say 2 is the next node in the path. Okay. So 2 is done. Next number is 5. Next number is 4. Okay. 5 is done. Now you need to search for those x for which you got the answer for the query as 4. They are your candidate for the next edge in the path. So you got 4 for x equal to 3 and for x equal to 6. So both of them are giving you an answer of 4. So if you would check whether there exists an edge from this node number 2 to that node giving you an answer of 4 or not. So there exists an edge from 2 to 3 and edge from 2 to 6. So basically you can take any one of them. Nodes, it doesn't matter. Even if you take 6, you would get this path having value 5. Any one of this path. Both of them would reach you to a value 5. You don't need to find all the paths. You need to find just any one path having maximum length. So you can take any one, 3 or 6. So you can just start checking in any order. First time that you get a node which for which an edge exists, you can just break out there. You don't need to check further. You can keep that as your next node in the path. Okay. Now after node number after value 4, this is done. Then you would check for value 3. So x equal to 4 has a value 3, x equal to 7 also has a value 3. So both of these 4 and 7. Does there exist an edge from 3 to 4? Yes, this is selected. There didn't exist an edge from 3 to 7, so 7 was not valid if it was checked before. So this node 4 got selected. Then you would check for a value of 2, x equal to 5 and x equal to 8. Both of them have a value 2. So does there exist an edge from the previous selected value from 4 to 5? Yes, there exists. So like 4 was selected, then 5 was selected. So this way, if you follow, then you check for 1, x equal to 9, there exists an edge, you write 9. So this way you can get the complete path. So initially you did this n queries. Then for getting the path, how many queries would be required? In the worst case, what would happen? That for every node, you check, like for 6, you checked. For the first node, you would always, for the maximum value, you would always pick any one x for which you get the maximum value. For then, let's say for 5, you check all the nodes having value 5, all the nodes having value 4, all the nodes having value 3. At max, you would check these n minus 1 times only. You wouldn't check more than n minus 1 times. So basically, at max, you would do 2n minus 1 queries only. And you have 2n queries, so there is no issues. Through this type of way, you can just find the exact paths. I hope if the logic is clear to you, you can just write down in the chat or if there is any doubt. Yeah, this is an universal property for DAG. If you have solved some standard problems on DAG, then this is how you find the length of the longest path. First, you do the topo sort and you move in the topological sorted order and do this. Yeah, you can ask. Uh, Finding 5 by 3 queries. What do you mean? Okay, so I didn't look at the editorial, so I have not thought of that yet. So yeah, currently, if I get some logic, maybe I'll write in the comments. Currently, I have not thought. Okay, I got it. Okay, is there any doubts in this logic, or if the logic is clear, we can move to the code. You should implement it. Okay, so let's move to the code part. Okay, so like for interactive problems, it's always suggested just make a query function to do your queries. So you don't have to write those C out scene again and again. You can use that function. So I have made the query function to do my queries. So uh, in every query, what I need to do is print a question mark, then your X, and then the length of your set and each element of the set. So this vec basically represents my set, and this X is my X. So basically for every query is the set and the initial point. So this is sufficient to do a query, and I see out question mark, then an X, and then the size of the vector, and then all the elements of the vector. So like I've written vec directly because I have already overloaded this in my template, but you can run a loop and print all the values. So like I've already overloaded in my template for a vector that print it space separated if I do a cout. But in general, you can run a loop to print all the values of the vector space separated. And then finally, don't forget the endl for interactive problems. If you don't put the endl, you are not flushing the output, so it would give you errors. Then you do int answer and scene answer, return the answer. Scene, you get the response to the query and return that. I've made this query function now. Let's look at the actual code. So there were t test cases, so I call this function for the t test cases, and for every test case, I'm solving my problem inside this function. So int n, and then n was the input. After that, what I need to do? First step is for every x from 1 to n, do a query. Okay. And along with doing the query, you also need to store some values, that which all values got a response as 3, which all values got a response of 5, which all values got a response of 4. That you need to store. So to store that, I'm using a vector of vector, that in this way, that if I get a response of 3, in at index 3, I would store a vector, a list of values of x for which I get a response of 3. So this way, whenever during my final finding the path way, if I am solving for 4, then I can just iterate through vec of 4, which would give me a list of all those x values which have answer as 4. So I'm using a vector of vector vec, so where vec I stores the list of values for which answer to the query is I. So basically, it is vec I just denotes the list of x for which answer to query is I. Okay. Now, I'll store. So what I'll do in order to make the query, I need a set for with all the values from 1 to n. So in a vector v, I store push back all values from 1 to n. This I would use for the queries. So I'll do all the n queries with the different x from 1 to n. So I iterate for every I from 1 to n, I do a query with x equal to I, and this v containing all the values of the vector as the set. Okay. If whatever is the response of this query, at that index, I'll push back I. Okay. So this gets updated. If the response for the query is I, then in vec I would push back. If the response for the query is, let's say, x, then in vec x, I would push back. Okay. I've written I and x opposite. You can imagine this as x in the code, then you would understand. So the answer for the query, whatever is the answer for the query, in that I'm pushing back I. This I is actually my x for which I got this answer. Okay, so this way my vec I is updated. Now I initialize my vector of answer. In this, I'll store the path. So starting with whatever the path I'm storing, this would be stored in my answer vector. Now I start with I is equal to n to greater than equal to I. So I need to find the maximum value of the query that I get. So I could have maximized it here in the response of the query also. Another way was I was already storing this vec I. So if there is any element present in vec n, that means some query is giving you a response of n, then you can start with that. And if vec n is empty, continue forward to vec n minus 1, n minus 2, likewise. Until vec I is empty, just keep continuing. Once vec I becomes non-empty, the first time when vec I becomes non-empty, so this int L is storing the last value, it is initialized to -1. So if it is -1, I currently don't have any value in the path. This is my current maximum value. I'll just push back vec I0. So vec I has the list of all values for which I get the answer as I. So just push back the first value as your first, because if there are like two values having a length 6, both are maximum, then you can take any one of them. Both of them would give you a length of 6. If you start, you can start with any of them. So I just start with randomly the first value present in my vector, and I update that as my last value, so that from the next time my last is updated, I need to use whatever was the last value to check whether there exists an edge or not. Okay, so this is done when my L was -1. After that, my L will be updated. So for other cases, I'll just iterate through all the values present in vec I. So these J's are the basically the values of the X for which my answer to the query was I. So I need to check whether there exists a path from my last value, this L, to this J. So we would iterate through all the values having, let's say for this having value 4x equal to 4 and 7. So we'll iterate through 4, 7, all of them in J. And we need to check whether there is exist a path from L to J or not. If there is exist a path from L to J, J is my next node in the path. So to check that, I do a query with X is equal to L and only L and J as the values present in my set. If the answer to the query is 2, that means there exists a directed edge from L to J, and that I'll push back in my J vector. Okay, so that I'll push back in my answer vector. That J I'll push back in my answer vector. I'll update my last as J, and I'll do continue. That I don't need to check for. I should write break here. Okay, there was no issue with this, but J2 vec I, yeah, I should write break here, because once I've got one answer, no need to check further. I can just break out, okay, from this loop. But you should continue for the next iteration for this. Okay. So once this is done, after that in your answer vector, you would have got the path. If you have iterated till I equal to 1, then for I equal to 1, you would get the last value in the node that would be updated to your answer vector. And you can just print your answer, exclamation mark, the size of your answer, and then all the values present in that answer vector. You should use a loop to print all the values, but as I explained, I have already that is there in my template, so I'm just directly writing. So, and the end bell. Okay, so I hope the code is clear to you. If there is any doubts in the code, okay, so okay, if there's no more doubts, I think there is nothing to analyze about time complexity. If you want to analyze still, n was very less, so this loop is taking order of n time, this loop is taking order of n time, and this is done n times, and this at max would also, like, in total you are traveling to every node once, so at max this is order of n only. But for every query also, like here, this is not order of n. If you are doing a query for this whole vector of size n, this query is actually taking an order of n time. So this every query would take order of n time. So overall, this loop would take n square time. Okay, this loop would take n square time, and this overall would be order of n only, because you can imagine like a graph, you are going to every node only once. Okay, and this query is of size 2 only. So basically, passing this vector won't take uh, any too much size. Okay. Maybe you can pass it by reference to reduce this n square, but actually it doesn't matter because for the constraints of the problem, even n cube was fine. Sum of n cube must not exceed 5 into power 3. So there was no issues with n square. So I have let it be. Okay. So overall time complexity is, you can say, order of n square, and the number of queries, maximum number of queries used here n queries, and here also maximum this would be n minus 1 times. So maximum in less than 2 n queries you are able to get it. So there is no issues, answer is accepted. And space complexity, I guess, would be, you're just using a vector of size n. This vector of vector would also have a at max size n only. At max 2 n pushbacks would be, n pushbacks would be done, so at max size n only. So space complexity is also of n. Okay, so I think we can move to the next problem if it is clear till here. No, I have not tried the 5 by 3 solution as yet. So any other queries? Okay, so I think we can move to the problem D. So problem D is chicken jockey. So Steve made the foolish decision to mine at night and came across a chicken jockey to the power n consists of n mobs stacked in order on top of each other, with mob 1 at the bottom and mob n at the top. Mob I initially has a health HI. Okay. In one attack, Steve can deal 1 damage to any mob. If any mob reaches 0 or less health, it dies, and all the mobs on top of it fall down. So, and forms a new stack. The bottom mob in the new stack takes 1 fall damage for every mob it was on top of before. And this may kill it as well, which in case all mobs on top of it fall again and process repeats. Okay, so basically I'll explain you what is happening here. So let's suppose uh, this is the example. So this just represents that there are mobs, n mobs, one on top of each other. So at the bottom there is a mob with health 1. At top of him there is a mob with health 2. Okay. Then a mob with health 1. Then a mob with health 3. Then a mob with health 5. Then a mob with health 2. Okay. This is how the stack is currently. Then what you can do in one operation, he can do 1 damage to any one of the mobs. Okay, so Steve, let's say, damages the third mob in the stack. Okay, let's say Steve does 1 damage to this particular mob. So after that 1 damage, it would get reduced to 0. So if its health reduces to 0, it would die. So once this guy dies, if any basically any mob in the middle of the stack dies, then all the mobs on top of it would fall below. Okay, so since it has died, this whole structure would fall below, and it would become like this: 3 5 2. Now when it falls below this, the lowermost mob would get a fall damage. Okay, since it has fallen, this would have an impact of a fall damage, and the amount of damage would be how high he was. So the number of mobs below him before this one was killed. So there were 1, 2, 3 mobs below him. So he would get a damage of 3. Okay. So after getting a damage of 3, his health will also become 0. And if his health also becomes 0, he would also die. And again, all these mobs on top of it would fall below like this. 5 2, and again this particular mob would get a fall damage of the height it was at before falling. So it was at a height of 1. Okay, here we won't consider a height of 4 because it got a damage when this died and this shift was done. So it got only a damage of 1. So -1 would make his health 4. Okay. Now, after this, so basically after doing this one attack, this is the final state after all the fall damage, that you have a stack with 2 and 4, and this stack with 1 and 2. These are the two stacks currently present. Okay. This stack which was already there, and this got fallen and became this. So after this one operation, there are two stacks now with like this. Now again, he can do one attack on any one of the stacks, and likewise again, it may break into two different stacks, or likewise something may happen. Finally, what he needs to do is just destroy all the mobs in minimum number of attacks. So you need to destroy all mobs in minimum number of attacks. In every attack, you just deal 1 damage. So what is the way to do this? For this particular problem, the optimal way was, after this, what you can do is maybe do an attack on this particular mob. Okay, so you have already done one attack here. Okay, then if you do an attack here, this would go to 0, it would fall, and he would get a 1 fall damage, and it would get reduced to 1. Then, so a +1 attack done. Then maybe you can do an attack on this and kill it completely with the next attack. So 3 attacks done. Then let's look at this stack. So you can maybe do 4 attacks on this and do it in 7, and then 8 would be required. What is the minimum for this test case? It is 7. Okay, so I think you can do it more optimally. Okay, I think one attack was used here, and then it reduced to 2, and after 4 attacks, and then one more attack will be required here. Okay, so a more optimal way here was, if you start attacking from this particular, from this particular 5. If you clear all the 5 from this, then it would fall. And if you clear from this, then it would fall. So 5 plus 1, 6, and then 1, 7, and 8 still. Okay, let's look. Okay, let's look at the optimal case for whatever is given in the example only. Okay. So if you look at the example test case to obtain what is optimal, like here in this way, I'm getting 8. Okay, so here I'll just complete this process. If you do 4 attacks here, this would get reduced to 0, and this would get 1 fall damage and get reduced to 1. So plus 4 attacks here. So 3 and 4, 5 attacks, and then plus 1 here. So a total of, in 8 attacks, you were able to clear all the mobs. But there is some way through which you can do it in 7 attacks as given in the test case. Okay, so we'll see when we solve the problem how do we obtain the optimal way. But for the example, let's take the first test case and understand what is the most optimal way. So here the most optimal way is, you have a 3, you have a 1, you have a 4, you have a 1, you have so for this case, you can, I think, uh, attack this one. Both of them would get killed. Attack this one. -2, 3, 5, and then. Okay, Steve can use one attack to damage the second mob in the stack. So he can use one attack to damage this. Okay. This get killed one attack. The next, this one would get 2 fall damage, and it would be like this. 4 minus 2 would be 2, and then 1 and 2 on top of this. Okay. In the next attack, what you can do is the third mobs do 2 damage, and these are the stacks. Now Steve killed the second mob in the second attack. Okay, so this second can kill the second mob in the second attack. And the third mob takes 2 damage to fall. Okay, so he can basically kill this particular mob in the next attack. And Yeah, in the next two attacks, he can kill it in two attacks, and then it would fall. This one would take a fall damage and become zero. Again, it would fall. It would take a fall damage and become one. I hope you understand. So after these three attacks, the states you have is uh, this one is a one, and you only have a three here. Okay, so one and three you have. So plus one damage for this and three damage to this. So in four plus three, total of seven attacks, you were able to do it. Okay, so for this case, seven was the most. Okay, so now you basically need to write some code and derive some way to find out what is the most optimal minimum number of attacks you need to do to kill all the mobs. Okay, so and the constraints for n is 2 into 10 to the power 5. Now, how do you solve this problem? As you could have understood that even if like I was trying to solve this test case, even like finding this 7 was through some brute or maybe through even just through some uh, try and error also, it was a bit difficult. So one thing you can realize, there won't be some very greedy approach that through some trial and error you can do. So what should come to your mind in this type of problem is decode. That that should be some dynamic way to do this, some dynamic programming approach. Okay, but if it didn't come to your mind, I'll give you the intuition why that should come to your mind. Let's look at how these things, how the operations are happening. Okay, so you have a stack. So you have a stack. So what is happening in every operation? If you try to think, in every operation, either like if you are doing an attack in the middle, so if it has like health 5, so doing an attack would just reduce it health to 4, no other effect. Then from 4 you can reduce it to 3, then 2, then 1. Only thing that you need to find a manage is when it completely dies out to 0, then something happens that this entirely falls down and then some changes happen. If it was like it doesn't fall down, then basically the sum of all the healths would be the required number of attacks. But actually that extra the how you are minimizing your amount of attacks is by the fall damage. The fall damage is the thing that you need to maximize. If you maximize the fall damage, it will minimize your answer. It's straight away like the total amount of fall damage you do, your final answer would be basically the sum of hi, whatever is the sum of hi that would be required if there was no fall damage, minus whatever is the fall damage. That is your answer. So if you want to minimize this, you need to maximize the fall damage. Now, how do you maximize the fall damage if you try to think? So you can do a fall damage when if you it has health 5, you can do 5 attacks and kill it completely. And then this element just on top of that would get this much amount of damage. Now, let's say you want to do a fall damage for every element. Okay. If you're killing some element, then this is not receiving any fall damage, but the element just above it is receiving the fall damage. So it cannot happen that all any two consecutive elements receive fall damage. They can like receive only one extra damage if uh, it again falls, because once it falls, okay, once this thing falls and the below one receives a fall damage, if it dies, then the element just above it would receive only a fall damage of 1. He would never receive more than 1 in one operation. So if this is getting killed, the element just above it may receive this much damage, but the element 2 above it may only receive a damage of -1 if this dies, otherwise no damage to it. It would never receive more than 1 damage by killing this. That's one thing. So basically, this one can be like a little bit ignored, because if it is not dying, apart from if you have a 1 here, then it would consecutively die. Okay, if you have a sequence of ones here, then they all would die in sequence in one operations only, one on top of each. But other than one, if there is anything else, your sequence would stop. After this falls, it receives some damage. If it dies, this becomes 1. If it doesn't dies, it remains 2. And once there is some element at the base, whatever is there at the base, he can never receive any fall damage. Whatever is there at the base, he should receive this at least X damage from your end in order to make in order to get killed. So that minimum operations would then be required. So only people who can receive damage is if they are not at the base. So now with these things in mind, what do you think? How should you proceed by making your operations? Let's say finally you are killing these, and these. Let's say there are some set of people whom you are killing, and then rest of the people are receiving fall damages and dying. Let's suppose. Okay. There would be some set of people whom you would be killing, and rest of the people would receive some fall damage and die. So what should be your order of killing those people? If you kill this person first, and this stack would come here, and then if you kill this person, the amount of fall damage that the person above it would receive would be this much only, because he is already killed. But if you kill, okay, and then again if you kill this, it would be this much only, this much only. But if you kill the topmost one that you had to kill first, the value, the mob just on top of it would receive this much damage. Then it would not affect the lower ones. Then if you kill this, he would receive this much damage. Then if you kill this guy would receive this much damage. So it's always better to start killing from the top and proceed down, because the higher you kill initially, the more amount of fall damage the person just above it would get. So this you can like basically prove actually that you would always start killing from the top. Okay, and once like you killed this and it got separated into this part and this part, this falls down into this, then these are two separate stacks which can be solved separately. You can assume this as a new problem, as a new set of stack for which you need to find the minimum number of operations to kill it completely, and this as a new stack for which you need to find minimum operations to kill it completely. So basically whenever you kill any particular element, any particular mob, the this full stack just above it becomes a new individual stack which should be solved separately. So what I'm telling is you can take a DP state like that let's say this is your I, then your DPI should represent that if you want to, if this was your original question, okay, if you started with this, all these below doesn't exist, let's suppose. Okay, if let's suppose you can somehow calculate this DP state, that you can calculate that if this much only was there as your original question, what would be your answer? So basically after falling, this becomes a new question, you are calculating the answer for that. Okay, then your final answer would be basically DP0. DP0 is for this complete stack, what is your answer? Then can you write transitions for that? Then what I'm telling is, okay, you have some stack like this. Okay, let's say I'm breaking it down at this index. Okay. Okay, so the order of operations would be, as I said, from the top. So there you would select some particular element which you would kill completely and make others fall down. And then you would try that for this how you can kill. So when like you can see when you kill this completely and then you're killing something here, then actually you're not following that order, that kill, because this was below, you are killing below and then you're killing something in the upper. So that is only followed when you want to get some fall damage. But for the case when this some part is left for which you would have to do all the damage with operations only, then you can say that you don't require to do it before or after. You can do it at the end when it is there at the base. Okay. So now, keeping that in mind, let's try to write the transition for that. Now, if I'm at an index I, what I'm telling is my DPI is if I had only this much as the problem given to me, then how what is my answer? Okay. Now, if you want to write the transition, there are two things that you can do. If this is the problem given to you, either you can kill it completely. Okay, there are two things. Either you can assume that this is the topmost killing that you are doing. Above that, they would be manually killed. Or this is the killing you are doing, and then above that, they would receive some fall damage. And then above that, there may be some other killing also done. They would be done before it, but you are calculating it here. So what actually I'm telling is, let's suppose for this, either it would be the case, if I'm calculating DPI, I kill it completely. Okay, think it like this. Either I kill it completely, then what would happen if I kill it completely? This I minus 1 index, he would receive a fall damage of this much. Okay, he would receive a fall damage of I. Okay, let's say I'm using zero based indexing in my code, so I'm explaining using zero based indexing. Okay, let's say I have zero based indexing. So the number of mobs here is actually I plus 1. Okay, if I'm at 1, number of mobs is 2. So I get I plus 1 damage at this. So my AI minus 1 would get a damage of I plus 1. This would be the health remaining with this particular mob. Now, if this remaining health is less than equal to 0, then he would also die. Okay. And if this is greater than 0, then you start a new, let's say this is greater than 0. Okay. Then in that case, you start a new stack with the lowermost element as AI minus 1 minus I plus 1. This would be the health of the lowermost element. Then you would require this much, at least this much amount of operations to kill it completely. So you can write this DP state as for killing this completely, you require AI number of operations for killing this state. And then for killing this state, you would require this much more amount of operations. If this is still positive, then this much more amount of operations would be required. And then you can say that for the remaining elements, it's like a DP that this stack was remaining with you. And why I'm also calculating this here, I didn't directly write DP of this, because this is getting some more amount of damage. When I'm calculating the DP I minus 1, I'm not considering this much amount of damage in it. I'm considering that it has a health of AI minus 1. So I have to, so I'll consider that I'll do this much amount of damage in this, and then I'll write whatever is the DP of I minus 2, whatever is the amount required for I minus 2. Now for I minus 2 also, he would get 1 damage. Then it would happen. So instead of taking a single DP state, I'm defining one more DP1 of I, which is if you have this much as the stack and the lower element gets 1 damage, then what is the minimum number of operations now required? Okay. So DPI was for this much stack, the number of operations required. DP1 of I is for this much stack number of operations required if the lowermost has received 1 damage already. Because X number of, here the damage is variable. You cannot have I number of DP states, but you can have 1 extra DP state for 1 damage. That's why for 1 damage, I'm taking this DP1. So this one way is do AI amount of damage here. Then whatever is the health remaining in it, do that much amount of health in that. And then take the DP, whatever is the DP to destroy this much in with lowermost having had 1 damage. This is one way. So it would be minimum among either this or if you assume, if you want to use dpi minus 1, maybe because here I'm using dpi minus 2, but maybe if I start fresh with this, that would have given me some lower value. Destroying this, maybe in one we can destroy this and get more amount of fall damage from here. For this one we can get more amount of fall damage. So if you want to consider this, then what I can say that let's take dpi minus 1. Let's take dpi minus 1, whatever amount is required to destroy all this. And once all this is destroyed, then just destroy it from the top using ai operations. So use ai operations to destroy this, and dp again, if you are like at the end destroying this and then this is coming, so it would have received 1 damage. This one would have received 1 damage. So instead of taking dp, I'll take dp1 again. Okay, so ai plus dp1 of I minus 1. So these are the two ways. Okay, either you kill it completely and make this one receive the complete fall damage of I plus 1, or use dp this, for which you would maybe make this one or some higher value to receive the complete fall damage. Here you are not making this receive the complete fall damage, you are making this receive only 1 damage, but something higher would receive the complete fall damage because it was higher. Okay, so this is how we calculate dpi. Now we have taken another dp1, so we also need to write a transition for dp1 of I. So what would be dp1 of I? dp1 of I is if the base has already taken 1 damage, so it's same as dpi with ai changed to ai minus 1. So dp1 of I would be minimum of, either you keep dpi only, if without taking damage only you are getting a better answer, then keep it like that only, keep dpi only. Or if it has received 1 damage, it's the base below it has fallen and it has received 1 damage, then you would use this case that ai minus 1 more damage will be required to completely kill it, and then dp 1 of I minus 1 would be required. Now, this particular case would not come in dp1 of I, because in dp1 of I am assuming that it has taken just 1 damage and it has already fallen. If it has already fallen, then the element just above it would not receive I plus 1 damage. It would receive only 1 damage if I am killing it here. So that's why for dp1, this case would not come. This case would only come if I'm killing it in the original stack. If I'm killing it in the stack which has come down after receiving a damage, for that it won't receive I plus 1 damage. So for original stack, only this case will be there. For dp1, I'm assuming that this stack just below me has fallen and I receive 1 damage. So this is how you write the transitions for your dpi and dp1 of I. And if both of these transitions you can see are O of 1 transitions. So overall, in order of n time, you can compute your solution. Okay. Is there any doubts in this? Just think once more about this, what actually I'm doing, if it is not clear. This case is basically when I'm making it fall from the original stack. So I plus 1 damage is received for the mob just above it. And this case is if I'm making it use AI damage to fall, and then I'm using dp1 of I plus 1 to represent it. The above stacks would somehow fall, whatever was the most optimal way for the above I minus 1 stacks to fall. Let them fall. After that, just use AI operations on top on this and make it make this also fall. This is that case, and this is the case when I'm making the above one fall from the original stack. And if above one falls from the original stack, then dp cannot be used because dp is for the original stack if you want to make the top I values to fall. Okay, actually my dp states are this. If you didn't understand what the states of my dp is, dpi is if make or just kill all mobs from I up till n, assuming you are on original stack, the initial stack, or you can say. And dp1 of I is kill all mobs from I up till n for a fallen stack. A fallen stack whose base has been killed, and then this ith. So basically, I plus 1 is the for the stack had fallen till I plus 1, and then this base was killed, and this I got 1 damage. So here it got 1 damage. So something like that is the definition of my DP states. Keeping these definitions in mind, I think you can think why I've written these transitions. Okay. DPI is for the original stack. You can do I plus 1 amount of damage on the I minus 1th element by killing this ith element. So kill ith element using AI damage. It would receive I minus 1 damage. Okay, here you need to write either this, or if this becomes negative, then you would replace it with 0. Okay, you it would be max of 0 comma this, because if this value becomes negative, that means you require 0 amount of damage to kill it. It is already killed, and you can move it dp 1 of I minus 2, because at I minus 2 you would get 1 damage. So you are using dp. So if this is positive, use this. If this is negative, use 0 here. Okay. So this much is the amount of damage that you need to do after the element just above it has fallen. After making I and I minus 1, killing both of them, dp I minus 2 represents to kill all. And this is if you kill all the above and then kill the ith one. Okay. Here you are killing all the above first and then killing ith one. Here you are killing ith and I minus 1 first, then killing above. Okay, I hope you understand. And dp 1 of I is basically either use the dpi or just make it has already received 1 damage, so do this much amount of damage and use dp1. Okay, if the states are clear, I think we can move to the code if there is any doubts. Rating would be a good problem, maybe above 1900, I'd say. Should be. Not sure. 1900, 2000, probably. Okay. So let's look at the code for this. Okay. So I take the input n and an array of size n. Then I initialize both of my dps, dp and dp1 of size n. Okay. So the base case that I'm taking here would be I'm calculating my dps from the top. So dp, this is my n minus 1th index. It is 0 based index. So n I'm assuming it as dpn. I'm saying that dpn means there are no mobs that exist. So its answer would be 0. No operations are required. Same way for dp1 of n. If no mobs exist, answer would be 0. This is my base case. And same like I'm using dp I minus 2 also. So I need to calculate 2 base cases, n as well as n minus 1. So my base case, I'll write is first is this dpn and dp1 of n both are 0. What would be my dp n minus 1? is for the topmost guy. Okay, either for the topmost guy, he can never receive any fall damage or anything. So you would have to use just an upper an minus one amount of operations to kill it because he is at the topmost. So this would be directly a n minus one, and dp one of n minus one is he has already received one damage, so it would be an minus one minus one. Okay, so dp n minus 1 is an minus 1, dp1 of n minus 1 is an minus 1 minus 1. Okay, base cases are done. Let's move to the transition. Start with n minus 2, calculate up till 0. Okay, so what is my transition? dpi is ai plus this particular value. This I am calculating in a variable x, max of 0 or ai plus 1 minus I plus 1. So, okay, I am taking it. Okay, I had written I minus 1. It should be above I have I plus 1. Okay, it's increasing here. So this would be dp1 of I plus 2. And here it should be I plus 1. Okay, so I hope you got that. It was a mistake. It should be I plus 2 because I'm moving up from here. Okay, here also dpi plus 1. Okay, so my transition would be a I plus 1 here also. So yeah, ai plus 1 minus I plus 1. So ai plus 1 minus I minus 1. This or 0. If this becomes negative, it will take 0. This I got in a variable x, and then my answer is either ai plus x plus dp1 of I plus 2, which is ai plus x plus dp1 of I plus 2, or ai plus dp1 of I plus 1. ai plus dp1 of I plus 1. And what is my dp1 of I? dp1 of I is mean of dpi, or ai minus 1 plus ai minus 1 plus dp1 of dp1 of I. Okay, I've written the transitions, and my final answer is just dpz. Okay, whatever is the dp for this, it actually calculates how to kill all the elements. Okay, this is my final answer. I hope the logic and code is also clear to you. If there is any doubt, please ask. Okay, if you analyze the time complexity, this input part is taking order of n time. These two DPs are created base cases, then this loop is running n times. All these inside are O1 operations. This is also taking order of n time. Overall time complexity is order of n, and space complexity you can say is using a two DPs of size n, a vector of size n, all the vectors are of size n. Space complexity is also order of n. Okay, so I hope the problem is clear to you. If there is any doubt, please ask, or we can end the session now. Any other doubt also? Yes. Okay, so thank you so much for tuning in. I guess we can say goodbye. How to improve DP? I'll say practice more and more. Practice some standard problem, like you can practice on CSES. That is like very basic. You should definitely practice that. And apart from that, there's you can find AdCoder DP contest. Uh, AdCoder editorial educational DP contest. It has some list of 25, 26 questions. That is also very nice. Practice those first, and then practice some random problems on Codeforces for DP. It's more and more practice, I'll say. Last test case of problem D. This test case. Yeah, you'll have to practice those non-standard DP problems as well, that you can do just by doing random problems. Okay, you are talking about this test case, right? So like for this test case, you have all 10 to the power 1, 2, 3, 4, 5, 6, 7, 8, 9, 1e9. All three are 1e9. So this is your initial stack. So I think what you can do here, using this much amount of operations. So basically you can just kill all the elements here using 1e9 operations, and this would receive one fall damage and become 1e9 minus 1. 1e9 kill all elements here using plus 1e9 minus 1 operations. It would receive a fall damage and become 1e9 minus 1. Kill all using 1e9 minus 1 operations. So plus 1e9 minus 1. In total, you got 3e9 minus 2 operations. So that's what is written here. Like there was no much fall damage that you can utilize here. So doing it in the brute way was only way. Even if you kill this one first, it would receive 2 fall damage. But again, this would also require 1e9, this would require 1e9, this would require 1e9. So that way also you would get 3e9 minus 2. So in these two ways you can get 3e9 minus 2. Yeah, if you kill the middle one first, this would receive 2 fall damage and become 1e9 minus 2. But here you required plus 1e9 operations, and this single one would also require plus 1e9 operations. So in total, 3e9 minus 2 only is required. Okay. I hope it's clear. Any other doubts? Okay. Thank you so much for tuning in, guys. Goodbye.